Good evening, everyone. Good evening, good evening. Good evening, everyone. Hope all of you can see me and hear me. Guys, if I'm audible and visible to everyone, just hit the chat box with the thumbs up fast. Just hit the chat box with the thumbs up fast. If I'm audible and visible to everyone. If I'm audible and visible to everyone, hit the chat box with the thumbs up. I'm sorry I was late for a few minutes because there was some sound issues and the technical issues you can call. I'm sorry for that. Yeah, there were some technical issues. That's why I was a bit late. Yeah. All right. Wonderful, guys. So as you all are familiar with, today we are again going to talk about one of the most important topics of the redox, which is the calculation of valency factor or calculation of N factor, right? In the last session, we talked about how to calculate equivalent mass of different substances. We talked about the ions. We talked about the salts, we talked about the acids, we talked about the bases, right? And people, today we are going to do something more interesting than that. Let me tell you, okay? But before starting with the session, let me introduce myself. My name is Wassim Sir and I am your chemistry master teacher over here, right? As you all must be knowing now. Wonderful, guys. So before starting the session, let me give you the brief idea about the JEE Pro subscription. Well, people, talking about the JEE Pro subscription, what all things you are going to get if you are getting this Pro subscription, what all things you are going to get apart from the YouTube teaching and all. You are going to get 5,000 plus hours of live online teaching in this Pro subscription. We are going to conduct regular tests and assignments will be given to you, which will contain 10,000 plus questions. That's one of the greatest things in this subscription. Wonderful. And people, we have got 20 plus teachers with 5+ years of experience over here. And it's completely your wish. Whosoever teacher you want to take, you can take it in this Pro subscription, right? And you have got the complete option to learn in English or Hindi. And what we are going to do over here is we are going to cover everything in this Pro subscription, and we are going to cover at the same time the micro courses and the crash courses as well. Everything will be done over here in this Pro subscription, right? Okay, guys, talking about the JEE 2021 Pro subscription for the people who are going to appear in JEE in 2021. People, we have got different plans for you. 1 month plan, 3 month plan and the 6 month plan. Okay. And in all the plans, you are getting 20% off, 20% off. And after the discount, the 1 month plan is for 6K. 3 month plan is for 16.8K and the 6 month plan is for 31.2K. All right. This is about JEE 2021 Pro subscription. Similarly, I have got one more Pro subscription for the people who are going to appear in JEE in 2022. And this is the Pro subscription for them. Okay. Again, we have come up with different plans: 1 month, 3 months, 6 months, 12 months. And again, over here, you are having the 20% off. After the discount, 1 month plan is for 4K. 3 month plan is for 10.8K. Similarly, 6 month and the 12 month as well, right? And for the people who I call droppers, and you all know today's droppers are tomorrow's toppers, we know that, right? So for the JEE droppers, people, for in your pro subscription, again we have come up with 3 plans: 1 month, 3 month and 6 month. Again, you are going to get 20% off in it, and after the discount, the 1 month plan you are going to get for 7.2K, and the 3 month plan you are going to get for 20.4, and the 6 month plan you are going to get for 40.8. Okay, exactly, guys. Today's droppers are tomorrow's toppers. And now the point is how to avail this discount. There is the link in the description box of the video. What you are going to do is just click on the link, apply the coupon code WBPRO. You are going to get 20% discount by using this coupon code over here. So people, should we start the today's session? Just give me the thumbs up in the chat box. Let me see the josh of today's session. Should we start the session? Are you guys damn excited, super excited for the today's session? Just hit the chat box with the thumbs up fast. I just want to see the josh of the today's session, guys, because today we are going to talk about one of the most important topics, as you all are knowing, which is going to be the N factor calculations, right? Wonderful, great. A lot of thumbs ups. Josh is high, yeah? That's wonderful, guys. That's wonderful. All right, so let's get started with the today's session. Okay. Now people, first of all, we are going to talk about the calculation of N factor, or we call it as valency factor, for oxidizing agents or reducing agents. How do we calculate the N factor? How do we calculate the valency factor? Or I can say, how do we calculate the equivalent mass, equivalent weight for the oxidizing agents or reducing agents? Let me tell you, equivalent mass of an oxidizing agent or reducing agent will be equal to the formula which I gave you yesterday. What was that? Molar mass of the substance, molar mass of the oxidizing or reducing agent divided by N factor of the oxidizing or reducing agent. In order to calculate the equivalent mass of the oxidizing or reducing agent, we must know the N factor of oxidizing agent or the reducing agent. Now the point is, how do we calculate this N factor for the oxidizing agents and reducing agents? Just people have a look. Just people have a look. N factor for an oxidizing agent or reducing agent is always equal to number of electrons exchanged per mole of oxidizing or reducing agent. What do we mean by that? What do we mean by that? Just have a look. Just have a look. Just give me a second, guys. Just give me a second. Have a look. As per this definition, in order to calculate the N factor of the oxidizing agent or the reducing agent, how do we do that? Number of electrons exchanged per mole of oxidizing agent or the reducing agent. First of all, let me tell you again what the oxidizing agent is all about, what the reducing agent is all about. See guys, oxidizing agent is the one which oxidizes other substance, but itself undergoes reduction. Right? Similarly, reducing agent is the one which reduces others, but itself undergoes oxidation. Right? Matthew, base was complete, right? That was the last question in the yesterday's session. Z and OH hold twice, right? The first answer was 1, second one was for 2. Okay. Now people, what I'm going to talk about, oxidizing agent and reducing agent. Oxidizing agent is the one which oxidizes others, but itself undergoes reduction. Similarly, reducing agent is the one which reduces others, but itself undergoes oxidation. And people, in the last class session, I told you, how do we define oxidation? Simply, oxidation involves increase in the oxidation state of an element, and reduction involves decrease in the oxidation state of the element, right? Very, very simple. Now people have a look. See how to apply all these concepts over here. I'm taking one general reaction to make you understand how to calculate the N factor of oxidizing agent or reducing agent. Okay, a general example I'm taking, general reaction I'm taking. For example, I have got the reaction like this: A plus B. Let's say it gives A positive plus B negative. Let's say this is one general reaction which I'm taking, okay? And what I'm doing at the same time, I'm assuming this A and B right here to be in their standard states. If A is right now in its standard state, its oxidation state will be 0. I'm assuming that. B, I'm assuming again to be in its standard state, so its oxidation state is again 0, right? Now people, this A positive over here, which is in the form of ion, and charge on an ion is equal to its oxidation state, okay? Charge on an ion is equal to its oxidation state, so oxidation state of A over here is +1 and oxidation state of B over here is -1, right? Very, very simple. Now people, have a look. In this reaction, A is changing its oxidation state from 0 to +1. A is changing its oxidation state in this reaction from 0 to +1. Can I say oxidation state of A is increasing? Okay, an increase in the oxidation state is what we call as oxidation. I would say A is undergoing oxidation over here. Right? Similarly, the oxidation state of B changes from 0 to -1 in the reaction. So the oxidation state of B is decreasing, basically 0 to -1. Decrease in the oxidation state is what we call as reduction. That means B over here undergoes reduction. And people, the substance which undergoes oxidation that acts like the reducing agent, we call that as the reducing agent. And the substance which itself undergoes reduction, we call it as the oxidizing agent. So A over here is the reducing agent and B over here in the reaction is the oxidizing agent. Now the point is, if I want to calculate the equivalent mass of this A and equivalent mass of this B, in order to calculate the equivalent mass of A and B, in order to calculate the equivalent mass of reducing agent and the oxidizing agent, I should know their n factors. Now the point is, how do we calculate their n factors? Have a look, guys, have a look. First of all, over here, initial oxidation state of A. This is the initial oxidation state of A. I can say this is the final oxidation state of A. This is the final oxidation state of A, right? Now people, in order to calculate the n factor, in order to calculate the n factor of A, what I'll be writing? I'll be writing change in the oxidation state of A. Change in the oxidation state of A. N factor of A is going to be equal to change in the oxidation state of A. That means final oxidation state of A minus initial oxidation state of A. Value comes out to be equal to 1. So I would say in this reaction, N factor of A is going to be 1. N factor of A is going to be 1. Very, very simple. Similarly, if I'll talk about B, which is my oxidizing agent, say, can I say this is the initial oxidation state of B and this is the final oxidation state of B? In order to calculate the N factor of B over here, what I'll be writing? I'll be writing N factor of B will be equal to change in the oxidation state of B, which will be equal to final oxidation state of B, which is -1 minus initial oxidation state of B, which is 0. The value will come again equal to 1. So I would say this 1 is the N factor of B over here. So this is how we calculate the N factor of oxidizing agents and reducing agents. Very, very simple. Okay, you just have to calculate change in the oxidation state of oxidizing agent or reducing agent, and whatever will be the change in the oxidation state of the oxidizing agent or reducing agent, that's going to be the N factor of that oxidizing or reducing agent. Okay, I'm giving you a few more examples. With that, things will get clear to you. Just have a look. For example, I've got a reaction like this. A2 plus B2. It gives, for example, twice A positive plus twice B negative. Let's say this is one general reaction which I'm taking. General reaction, in order to make you understand the concept of N factor for the oxidizing and reducing agents. Okay, now people see. Have a look. I'm assuming this A2 right here to be in its standard state. I'm assuming this B2 right here to be in its standard state. So their oxidation state should be 0. Correct? Now people see. Over here, what is the charge present on A? +1. So +1 is going to be the oxidation state of A. What is the charge present on this B over here? -1. So -1 is going to be the oxidation state of B over here. Correct? Very, very simple. Now people, can I say that A changed its oxidation state from 0 to +1? A is changing its oxidation state from 0 to +1, and B is changing its oxidation state from 0 to -1, right? Can I say over here the oxidation state of A is increasing? The oxidation state of A is increasing. Can I say over here the oxidation state of B is decreasing? And we know increase in the oxidation means oxidation. I would say A2 over here undergoes oxidation. A2 over here undergoes oxidation. Similarly, this B2. What is happening to the oxidation state of B over here? Oxidation state of B is changing from 0 to -1. So the oxidation state of B2 over here is decreasing, and decrease in the oxidation state is what we call as reduction. So this B2 undergoes reduction over here, right? And people, the substance which undergoes oxidation, that's what we call as the reducing agent. Correct? That's what we call as reducing agent. And the substance which undergoes reduction, that's what we call as oxidizing agent. Correct? Now the point is, how do we calculate the N factor of this reducing agent and this oxidizing agent over here? Have a look. I'm going to write N factor for A. N factor of A will be equal. What is the change in the oxidation state of A? I will say this is the initial oxidation state of A. This is the final oxidation state of A. So what is the change in the oxidation state? That is final oxidation state of A minus initial oxidation state of A. Value is coming out to be 1. this one is the change in the oxidation state. This one is the change in oxidation state for one atom of A, But how many atoms of A do we have? We have two atoms. What I'm saying is, this one over here, this is the change in the oxidation state for one atom of A. But I do not have only one atom, I have got two atoms. So for two atoms, what should be the change? I'll simply multiply it by 2. So n factor of A2 over here, which is my reducing agent, it's going to be 2. It's going to be 2. Very, very simple, correct? Similarly, talking about B2, n factor of B2, I will say, n factor of B2 will be equal, change in the oxidation state of B, which is the final oxidation state, -1, minus initial oxidation state of B, that is 0. So the value over here is coming as 1. But this one is the change in the oxidation state for one atom of B. And how many atoms of B do I have? I have two atoms, so I'm multiplying it by 2. So n factor of B2 over here comes as 2. Is this clear to everyone? Just hit the chat box with the thumbs up if you got the concept. Wonderful, wonderful, wonderful. Now guys, one more important thing. For example, this is the same reaction I have. For example, over here I've got some stoichiometric coefficients as well. For example, 5 and 2. Stoichiometric coefficients have got nothing to do with the n factor. Over here. Okay? See, n factor of A2 again will remain same as 2. N factor of B2 again will remain same as 2. These stoichiometric coefficients, they are not going to affect your n factors over here. Got it? Remember this important point. Okay? I'm moving ahead and let's talk about the same concept a bit in detail. Have a look, guys. The first oxidizing agent which I'm taking over here, yes, Bhargav. Yes, we'll do. Yes. The first oxidizing agent which I'm taking over here is KMnO4. KMnO4 is considered as the strong oxidizing agent. And this KMnO4, it shows different reactions in different mediums. Okay, KMnO4 shows different reaction in acidic medium, basic medium, and in neutral medium. Okay, first thing, KMnO4, it acts as a strong oxidizing agent, very, very strong oxidizing agent. And this KMnO4, it shows different reactions in acidic medium, neutral medium, and the basic medium over here. Just have a look, guys. Understand what I'll say. See, I'm talking about KMnO4. Either you write KMnO4 or you write MnO4 negative, one and the same thing. Either you write KMnO4 or you write MnO4 negative, one and the same thing. Now people, remember from now onwards, in acidic medium, this KMnO4 or MnO4 negative, in acidic medium, it changes to Mn positive. In neutral medium, this MnO4 negative, this KMnO4, it changes to MnO2. And in the basic medium, the same MnO4 negative, or I would say the same KMnO4, it changes to MnO4 di negative, right? Now people understand. Let's try to calculate the oxidation state of Mn over here. Can we do that? Let's assume the oxidation state of Mn is X plus oxidation state of oxygen is -2, right? How many oxygen atoms do we have? 4. What is the charge present on it? -1. So the value of X comes to be equal to as +7. So +7 is the oxidation state of Mn over here. Right? Now people, have a look. In this Mn positive is the ion, its charge is +2, so its oxidation state is going to be +2. What about the oxidation state of Mn over here in MnO2? It is simply going to be +4. You can use the formula X plus -2 into 2 is equal to 0. The same thing which we have discussed, right? The oxidation state of Mn over here is going to be +4, correct? What about the oxidation state of Mn over here? What about the oxidation state of Mn in MnO4 dinegative? It's going to be, let's assume the oxidation state of Mn is X plus oxidation state of oxygen is -2. How many oxygen atoms do we have? 4 is equal to, what is the charge present on it? -2. So I will say the value of X will come as +6. So +6 is the oxidation state of Mn in this MnO4 dinegative, right? Now people, what I'm telling you, this KMnO4 or MnO4 negative, it acts as the oxidizing agent. If KMnO4 acts as the oxidizing agent, then it should undergo reduction. itself, it should undergo reduction, because oxidizing agent is the one which oxidizes others, but itself undergoes reduction. So this KMnO4 should itself undergo reduction. Just have a look. In acidic medium, the oxidation state of Mn changes from +7 to +2. The oxidation state of Mn changes from +7 to +2, right? In acidic medium, correct? Now people, if I want to calculate the N factor of this MnO4 negative in acidic medium, can we do that? Can we do that? N factor of KMnO4, or I can say N factor of MnO4 negative in acidic medium is going to be equal. This is the initial oxidation state of Mn. This is the final oxidation state of Mn. What is the change in the oxidation state of Mn? That is final oxidation state, which is +2, minus initial oxidation state, which is +7. So the value will come as 5. So remember, N factor of KMnO4, or I would say N factor of MnO4 negative in acidic medium, it's going to be 5 always. Remember this. The N factor of KMnO4 or MnO4 negative is 5 in the acidic medium, right? Now similarly, we can talk about the neutral medium as well. See, in the neutral medium, the oxidation state of Mn changes from +7 to +4. In neutral medium, the oxidation state of Mn changes from +7 to +4, right? What is the change in the oxidation state of Mn, which is going to be equal to final oxidation state of Mn, which is +4, minus initial oxidation state of Mn, which is +7. Value will come as 3. So I would say 3 is the N factor. of this KMnO4 or MnO4 negative in neutral medium. I can say that. Now talking about the basic medium. In basic medium, this Mn changes its oxidation state from +7 to +6. In basic medium. If I want to calculate the N factor of this KMnO4 in basic medium, which will be equal change in the oxidation state, which is going to be equal to final oxidation state of Mn, which is +6, minus initial oxidation state of Mn, which is +7. Value will come as 1. So remember from now onwards, the N factor of KMnO4 in acidic medium is going to be 5. The N factor of KMnO4 in neutral medium is going to be 3. The N factor of KMnO4 in basic medium is going to be 1. People, is this clear to everyone? You can have a look also. In every case, oxidation state of Mn is decreasing. First, from +7 to +2 in acidic medium, +7 to +4 in neutral medium, +7 to +6 in basic medium. That means in every case, the oxidation state of manganese over here is decreasing. And decrease in the oxidation state is what we call as reduction. That means this KMnO4 or MnO4 negative in all the 3 cases is undergoing reduction. And that substance which itself undergoes reduction, that's what we call as oxidizing agent. Is this clear to everyone? Wonderful, guys. Wonderful. Great, I'm sure this is clear to everyone, right? Wonderful. Okay, now people, what I told you is, this KMnO4, it acts as the strong oxidizing agent. So we are going to talk about certain reactions of this KMnO4. in KMnO4. People, see, just have a look. Let's say I've got a reaction as A plus B gives something plus something. If A is the oxidizing agent, then B should be the reducing agent, right? One will be the oxidizing agent, one will be the reducing agent, right? If in a reaction KMnO4 is participating, is participating, right? And KMnO4 in acidic medium, basic medium, as well as neutral medium, it is acting like the oxidizing agent. So the other one, which is going to react with this KMnO4, that should itself act as the reducing agent, right? Example, have a look what I'm going to say. What I said is KMnO4 is acting as the strong oxidizing agent and it converts. And this KMnO4, this MnO4 negative, it acts as a strong oxidizing agent and it converts Fe di positive to Fe tri positive. It converts Fe di positive to Fe tri positive in acidic medium, right? It converts Fe di positive to Fe tri positive in acidic medium. Okay. Now the point is, what should be the reaction? Now the point is, what should be the reaction? What I told you is, this KMnO4 or MnO4 negative or MnO4 negative, it converts Fe dye positive. It converts Fe dye positive in acidic medium. This H positive represents your acidic medium. This MnO4 negative or KMnO4, it converts this Fe dye positive in acidic medium into Fe tripositive. In Fe tripositive. And we know in acidic medium, this MnO4 negative changed to Mn dye positive. It changed to Mn dye positive, and with this, water will get released. This will be the reaction when this MnO4 negative reacts with Fe dye positive in acidic medium, and it converts Fe dye positive to Fe tripositive, and itself in acidic medium it gets converted to Mn dye positive. People, is this clear to everyone? Is this clear to everyone? Is this clear to everyone? Just hit the thumbs up. Hit the thumbs up. Hit the thumbs up fast. Wonderful, wonderful, wonderful. Now people see, I told you in the beginning, MnO4 negative is my oxidizing agent. It is my oxidizing agent. That means this Fe dye positive should be my reducing agent. Now it is the time to calculate the N factor of these oxidizing agents and reducing agents, right? Now people have a look. Now people have a look. If I'll ask you, what is the oxidation state of Mn over here? It is +2. What is the oxidation state of iron over here? It is +2. Okay. Oxidation state of Mn over here is +7. Oxidation state of Fe over here is +2. Oxidation state of Fe over here is +3. And the oxidation state of Mn over here is +2. Right? Now just have a look. The oxidation state of Mn is changing from +7 to +2. Correct? Similarly, the oxidation state of iron is changing from +2 to +3. Correct? Can I say the oxidation state of Mn over here is decreasing? Decrease in the oxidation state is what we call as reduction. So this MnO4 negative is undergoing reduction, and that substance which undergoes reduction, that's what we call as oxidizing agent. Correct? If I'll ask you, what is the N factor of this MnO4 negative in this reaction? Simply you will say N factor of this MnO4 negative over here will be equal to change in the oxidation state. Initial oxidation state of Mn over here is +7. Final oxidation state of Mn over here is +2. So magnitude of final oxidation state of Mn minus initial oxidation state of Mn, right? So the N factor of MnO4 negative over here in this reaction is 5. Correct? Similarly, can I calculate the N factor of iron over here in this reaction? See, this is the initial oxidation state of iron. This is the final oxidation state of iron. So what do you think should be its N factor? N factor is going to be equal to final oxidation state of iron, which is +3, minus initial oxidation state of iron, which is +2. So the value will come as 1. So over here in this reaction, I would say N factor of Fe dye positive is going to be 1. If I got to know one, just say yes or no in the chat box fast. Just say yes or no in the chat box fast if this is clear to everyone. Wonderful, wonderful, wonderful. Great, great, great. Great, guys. Just hit the chat box with a thumbs up fast. Just hit the chat box with a thumbs up fast. Oh, great, guys, great. Okay, I'm moving on to one more. See, this is the reaction which I showed you. KMnO4 or MnO4 negative, it acts as a strong oxidizing agent. It converts Fe dye positive to Fe tripositive, number 1. Similarly, the same MnO4 negative, the same KMnO4, it converts C2O4 dye negative to carbon dioxide in acidic medium. It converts C2O4 dye negative, just give me a second, it converts the same MnO4 negative, converts C2O4 dye negative in acidic medium. This H positive represents acidic medium. Okay, MnO4 negative converts C2O4 dye negative to carbon dioxide. It converts it to carbon dioxide, and we know MnO4 negative in acidic medium itself gets converted to Mn dye positive, and over here I'm going to keep water as well. Okay, this is the reaction which will take place over here. This is the reaction which will take place when MnO4 negative reacts with the oxalate ion. It converts the oxalate ion to carbon dioxide. Now it is the time to calculate the N factors of both the two. Now comes the point. See, in acidic medium you can directly say N factor of MnO4 negative is going to be 5. You are not supposed to calculate it again and again, because in the beginning itself I told you N factor of MnO4 negative in acidic medium is going to be 5. Now talking about this oxalate, see guys, First of all, if you will calculate the oxidation state of carbon over here, you can do that. 2x minus 8 is equal to minus 2, so you'll get the value of x as plus 3 over here. The oxidation state of carbon over here in oxalate ion is plus 3, right? And this oxalate ion, it is getting converted to carbon dioxide. In carbon dioxide, what is the oxidation state of carbon? It is plus 4. So just have a look. The oxidation state of carbon is changing from plus 3 to plus 4. Right? Is the oxidation state of carbon increasing or decreasing? It is increasing. Increase in the oxidation state is what we call as oxidation. That means this oxalate ion undergoes oxidation. If it undergoes oxidation, that means it is the reducing agent. Now calculate its N factor. It's going to be equal to, see guys, a lot of people are saying 3, a lot of people are saying 2. Have a look. N factor of this oxalate ion. This is the final oxidation state of carbon. This is the initial oxidation state of carbon. Final oxidation state of carbon minus initial oxidation state of carbon. The value will come as 1. But this one is the change in the oxidation state. This one is the change in the oxidation state for one atom of carbon. But how many atoms of carbon I have? I have 2 atoms of carbon. So I'll simply multiply it by 2. So N factor of oxalate ion in this reaction is going to be 2. Is this clear to everyone? Wonderful, great guys, great. I'm moving on to one more. The same reaction which I showed you, MnO4 negative, which is a strong oxidizing agent. It converts oxalate ion in acidic medium to carbon dioxide. Very simple, right? Okay. Now people, the same MnO4 negative, the same KMnO4, it is converting I negative to I2. It converts I negative to I2. The same KMnO4, or I would say MnO4 negative, converts I negative in acidic medium to, it converts I negative to I2, right? And in acidic medium, this MnO4 negative, it gets converted to what? It gets converted to Mn di positive, and with this I'm writing water as well, right? What is this H positive for, if I'll ask you? This H positive just represents that the reaction is taking place in acidic medium. That's it, okay? Now people see, oxidation state of Mn over here plus 1, oxidation state of iodine over here minus 1, I2 over here 0, Mn over here is plus 2, correct? Very simple. Now, if I need to calculate the oxidation state of MnO4 negative and I negative over here, I'll simply do one thing. Have a look. MnO4 negative in acidic medium, already we remember its N factor is 5 in acidic medium, correct? Now people, talking about the N factor of I negative, okay? N factor of I negative over here will be equal. This is the initial oxidation state of I negative. This is the initial oxidation state of iodine. This is the final oxidation state. Calculate the change in the oxidation state, which is going to be final oxidation state of iodine minus initial oxidation state of iodine. The value will come as 1. So 1 is the N factor of this I negative in this reaction. Is this clear? If you got the N factor of both the ones, you can calculate their equivalent masses as well. You can calculate their equivalent weights as well. Okay, over here we have got just one I. I have got nothing to do with this. I'm calculating the N factor of I over here. Over here I've got only one I. This is only one I. That's why I'm not multiplying it by 2. I've got nothing to do with this one. Getting it? Very simple. Great guys, great. Let me move on to one more. Okay, this is the reaction which I showed you just now. Let me move on to one more. The same MnO4 negative, it converts H2S to S. Okay, the same MnO4 negative, the same MnO4 negative or KMnO4, it converts H2S. In acidic medium to, it converts H2S to sulfur. And we know in acidic medium, this MnO4 negative gets converted to Mn di positive, and with this I'm writing water as well. Very simple, right? Now people, MnO4 negative in acidic medium, its N factor is going to be 5. Correct? Now calculate the N factor of H2S over here. See, first of all, calculate the oxidation state of sulfur over here. It is going to be minus 2. You can do that now. Okay. And this H2S is getting converted to sulfur. And sulfur over here, its oxidation state will be simply 0. There is no charge on it. right? Now people, the N factor of H2S is going to be equal. This is the final oxygen state of sulfur. This is the initial oxygen state of sulfur. Magnitude of final oxygen state of sulfur minus initial oxygen state of sulfur. Value will come as 2. So 2 is going to be the N factor of H2S in this reaction. People, just tell me, is the concept clear to you? Just tell me, is the concept clear to you? Fast, fast, fast. Fast, fast, fast. I want everyone to say it fast if the concept is clear to you. I'm waiting guys, fast. I'm just looking at your chats. Great, 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 wonderful. Wonderful guys, great. So now let's move on. Now let's move on to one more. The reaction of MnO4 negative, okay? See, this is the reaction which I showed you just now. Now people, the same MnO4 negative, it converts hydrogen peroxide to oxygen in acidic medium, okay? It converts H2O2 to oxygen in acidic medium, just like this, wait. The same MnO4 negative, the same MnO4 negative, it converts H2O2, hydrogen peroxide, in acidic medium. This H positive represents acidic medium, okay? The same MnO4 negative converts H2O2 in acidic medium to H2O2 to oxygen, and at the same time this MnO4 negative in acidic medium, we know it gets converted to Mn di positive, right? And with this it will give some water as well. Very, very simple, okay, very simple. Just have a look now. See, MnO4 negative right now is in acidic medium, so can I say its N factor simply will be equal to 5? I'm not supposed to calculate. You can calculate that as well if you want. Now people, tell me what is the N factor of H2O2 over here. Tell me guys, N factor of H2O2 over here. I'm waiting for you. Tell me fast. What do you think? Oh, a lot of people are saying 4, huh? Is that? Okay, have a look guys, have a look. See, if you remember, I have showed you the structure of H2O2. In H2O2, there is a peroxide linkage, and in peroxide linkage, there was -1 charge on oxygen atom. So over here, oxygen will have -1 oxygen state, okay? It's not going to be present in -2. It's going to be present in -1 oxygen state. And look here, this H2O2, it is getting converted to O2. And O2 right here is in elemental state, standard state. Its oxygen state is 0. Just have a look. It is changing its oxygen state from -1 to 0. N factor will be equal to magnitude of. This is the final oxygen state. This is the initial oxygen state. Final is 0 minus. Initial is -1. Value will come as 1. Do I call this one as the N factor of H2O2? Do I call this one as the N factor of H2O2? No way. This is the change in the oxidation state for one atom of oxygen. But how many atoms of oxygen do I have? I have 2 atoms of oxygen. So I'm multiplying it by 2. So the value is coming out to be 2 over here. So I would say N factor of H2O2 over here will be 2. Is this clear to everyone? Wonderful. Great, guys. Great. So remember, your MnO4 negative, it converts hydrogen peroxide to oxygen, and you can calculate the N factor over here as well, right? Okay, I'm moving on to next one. This is the reaction which I showed you just now. Okay, I'm moving on to one more. This same MnO4, the same MnO4 negative converts Sn di positive. It converts Sn di positive in acidic medium to, it converts Sn di positive to Sn plus 4, and we know MnO4 negative in acidic medium itself gets converted to Mn di positive, and with this I'm writing water as well, Now people, oxidation state, everything is done. See, over here, MnO4 negative in acidic medium, its N factor is simply going to be equal to 5. Correct? What about the N factor of Sn di positive over here? Have a look. Sn di positive, its oxidation state right here is +2. Over here, its oxidation state is +4. So this is going to be the final oxidation state of 10. This is going to be the initial oxidation state of 10. N factor of 10 over here is going to be equal final oxidation state of 10, which is +4, minus initial oxidation state of 10, which is +2. The value will come as simply 2. So 2 is the N factor of 10 over here. Is this clear? Is this clear? Wonderful. Great, 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 great. Okay. One more. Have a look. One more, guys. This is the reaction which I just now showed you. Okay. Okay. The last one over here. I'm talking about KMnO4, right? And KMnO4 in acidic medium. Your KMnO4, or I call it as MnO4 negative, or I can write MnO4 negative, it converts SO2 in acidic medium. This H positive represents acidic medium. It converts SO2 to SO4 dinegative, right? And MnO4 itself in acidic medium gets converted to Mn di positive, and with this we'll be having some water as well. Correct? Now it's done. N factor of MnO4 negative over here, since it's an acidic medium, it's going to be 5. What do you think should be the N factor of SO2 over here? I'm waiting for your answers. Fast, guys. I'm waiting for your answers. Okay. Rajashri is saying 2. Banu Prakash is saying 2. Okay. Dadak girl is saying 2. Okay. Okay, great. Now people see. First of all, what is the oxidation state of sulfur over here? +4. Oxidation state of sulfur over here, +4, you can calculate it. What is the oxidation state of sulfur over here? It is +6. You can calculate it. X minus 8 is equal to -2, so X will be +6. So oxidation state of sulfur is changing from +4 to +6, right? So what is the change in the oxidation state of sulfur? Which will be equal to final oxidation state of sulfur minus initial oxidation state of sulfur, which is +4. Can I say the value will come simply as 2? Correct? So 2 is going to be the N factor of SO2 in this reaction. People, is this clear to everyone? Just hit the chat box with the thumbs up if this is clear to everyone. Just hit the chat box with the thumbs up fast. I want everyone to know. I want everyone to do it right now. Fast, guys. Fast. I'm waiting for you. Do it fast. Wonderful. Great job. Oh, that's great, guys. Okay, I'm moving on to one more oxidizing agent. See, till now, we talked about KMnO4 and its reactions with the different substances in acidic medium, right? And we saw how to calculate the N factor of different substances which were reacting with KMnO4 in acidic medium, correct? Now, people, I have got one more for you. Which is, just give me a second, which is K2Cr2O7. Potassium dichromate, K2Cr2O7. This is again a oxidizing agent. It again acts like the oxidizing agent. Like your KMnO4 that was acting like the oxidizing agent, similarly this K2Cr2O7, it is again going to act like your oxidizing agent. Okay, and let me tell you, in acidic medium, this K2Cr2O7, either you write K2Cr2O7 or you write Cr2O7 dinegative. Choice is all yours. Either you write K2Cr2O7 or you just write Cr2O7 dinegative. In acidic medium, this K2Cr2O7, this Cr2O7 dinegative, it is going to get converted into Cr tripositive. Okay, have a look, guys. Wait, there is a mistake in the slide. We can rectify it as well. Just give me a second. This is not MnO4 negative here. Okay, I'm writing over here. I'm writing a new reaction. Okay, I'm writing Cr2O7 dinegative. Either you write Cr2O7 dinegative or you write K2Cr2O7. The choice is all yours. Okay, Cr2O7 dinegative in acidic medium gets converted to Cr+3. Remember it. It gets converted to Cr+3. People, just tell me the N factor of Cr2O7 dinegative here. Just tell me its N factor fast. I'm waiting for your answers. What should be the N factor of Cr2O7 dinegative right here? What do you think? Jumana is saying 6. Mariam is saying 6. I want everyone to give it a try. Okay, okay. Digala is saying 6. Dadak girl is saying 6. Okay, okay, okay. Sai Reddy is saying 6. Santosh is saying 6. I want everyone to give it a try. Sahana is saying 6. Okay, Memes King 6. Dia 6. Ashwarya 6, JD 6, Vanitha 6. Wonderful, guys. Great. Have a look how to do it. Have a look how to do it. See, very simple. First of all, I'll calculate the oxidation state of chromium over here. Let's assume the oxidation state of chromium is X. And how many chromium do we have? We have 2 chromium, right? Apart from this, we have got oxygen as well. What is the oxidation state of oxygen? That is -2. And how many oxygen do we have? 7. What is the charge present on it? -2. Can I say X value over here is going to be +6? Right? X value is going to be +6. That means the oxidation state of chromium over here is +6, right? Now this Cr2O7 dinegative in acidic medium, it is getting converted to Cr tripositive. And in Cr tripositive, what is the charge? +3. So +3 is going to be the oxidation state of chromium over here. Now people have a look. Can I say this is the initial oxidation state of chromium? Can I say this is the final oxidation state of chromium? Now let's calculate the N factor of this Cr2O7 dinegative. Its N factor is going to be equal to. Just calculate the change in the oxidation state, which is going to be final oxidation state minus initial oxidation state. Final is +3, initial is +6, value will come as 3. Can I call this 3 as the N factor of Cr2O7 dinegative? Can I call it? Can I call this 3 as the N factor of Cr2O7 dinegative? No way, no way. Why is that? Because this 3 is the change in the oxidation state for 1 atom of chromium. And how many atoms of chromium do we have? We have 2 atoms. This 3 is the change in the oxidation state for 1 atom of chromium. I have 2 atoms. So I'll simply multiply it by 2. The value will come as 6. So remember, from now onwards, the N factor of potassium dichromate in acidic medium is always going to be 6. If you got the N factor of this potassium dichromate, you can easily calculate its equivalent mass as well. Molar mass of this divided by 6. Very, very simple. People, just hit the chat box with the thumbs up if you got the concept. Fast. I have to show you a lot of reactions of this K2Cr2O7 as well. Just hit the thumbs up in the chat box fast. Till then, I can have some water. Wonderful, guys. Great. Wonderful. I want a lot of thumbs ups, guys. I want a lot of thumbs ups. I want a lot of thumbs ups now. Okay, great. Okay, I'm moving ahead, and let me tell you, like your KMNO4, like your potassium permanganate, which was a strong oxidizing agent, again this K2Cr2O7, it's again a strong oxidizing agent. It's considered as the strong oxidizing agent. Now we have to check its reactions. The way we checked the reactions of KMNO4 with different substances, in the same way we are going to check the reactions of K2Cr2O7 with different substances. Now people, let me tell you, just give me a second. This K2Cr2O7 in acidic medium, I'm talking about K2Cr2O7, right? I'm talking about K2Cr2O7, or you can simply write it as Cr2O7 dinegative. Let me tell you, this Cr2O7 dinegative converts this Fe di positive, in acidic medium. This H positive represents acidic medium. It converts this Cr2O7 dinegative, converts Fe di positive to Fe tripositive, and itself in acidic medium, it gets converted to Cr +3. And with this, I'm writing some water as well. I'm putting some water as well. Very, very simple. Right? Okay. Have a look, guys, now. What is the N factor of Cr2O7 dinegative in acidic medium? You are not supposed to calculate it. We just remember it from now onwards. It's 6. Or you can do it as well. Oxidation state is +6. Oxidation state is +3. Calculate the change in oxidation state, which will be 3. But we have 2 atoms of chromium. 3 multiplied by 2 is 6, which we know, right? So this 6 is the N factor of Cr2O7 dinegative over here. Now people, just tell me the N factor of this Fe di positive right here. Tell me the N factor of Fe di positive right here. I'm looking at your chats only. Tell me the N factor of Fe di positive right here. Tell me fast. Very simple. N factor of Fe di positive will be equal. This is the initial oxidation state. This is its final oxidation state. So final oxidation state minus initial oxidation state, value will come as 1. So 1 is the N factor of Fe di positive in this reaction. In this reaction, people, is it clear to everyone? Wonderful. Great, great, great. I'm seeing a lot of Josh in the chats today after so long. Wonderful, guys. Great. Great, great, great. Okay, so this is the first reaction. This is the first thing, Cr2O7 di-negative or K2Cr2O7, it converts Fe di positive to Fe tri positive, right? I'm moving on to one more. Before that, this is the reaction which I showed you just now. This is the reaction which I showed you just now, right? I'm moving on to one more. Let me tell you, the same Cr2O7 di-negative, it converts oxalate ion to carbon dioxide. It converts the same Cr2O7 di-negative, the same K2Cr2O7 converts this oxalate ion in acidic medium to this Cr2O7 di-negative converts in acidic medium this oxalate ion to carbon dioxide, and itself it gets converted to Cr plus 3, and with this it will give some water as well, very simple. The first thing, N factor of Cr2O7 di-negative in acidic medium, we already know it is going to be 6, right? Now talking about N factor of this oxalate ion over here, if you will check the oxidation state of carbon right here in this compound, it's going to be plus 3, and this oxalate ion is getting converted to carbon dioxide, and in carbon dioxide the oxidation state of carbon is plus 4, right? So what should be its N factor right here? It's going to be equal to change in the oxidation state of carbon, right? Final oxidation state of carbon minus initial oxidation state. Final is plus 4, initial is plus 3. The value will come as 1. People, is this 1 the N factor of oxalate ion? Is this 1 the N factor of oxalate ion? No way, no way. Why is that? This 1 is the change in the oxidation state for one atom of carbon, But how many atoms of carbon do we have? We have 2 atoms of carbon. So I'm going to multiply it by 2. So N factor of oxalate ion over here is going to be 2. Very simple. Very simple, correct? Wonderful. Okay, this was the second reaction which this K2Cr2O7 shows when when it reacts with oxalate ion, it converts the oxalate ion into carbon dioxide and itself gets converted to Cr plus 3, right? There are few more reactions. See, this is the reaction which I showed you just now. Okay, after this, let me tell you the same Cr2O7 di-negative, the same potassium dichromate, or instead of potassium dichromate, I can simply write Cr2O7 di-negative, right? The same Cr2O7 di-negative converts I negative. It converts I negative in acidic medium to, it converts I negative to I2. And the same Cr2O7 di-negative in acidic medium, it changed to Cr plus 3. And with this, I'm putting some water as well. Now people tell me the N factor of every substance over here. N factor of Cr2O7 di-negative in acidic medium, that's going to be 6. N factor of I negative over here will be equal. What is the oxidation state of iodine right here? It's minus 1. What is the oxidation state of iodine over here? It is 0. This 0 is the final oxidation state. This minus 1 is the initial oxidation state. So final minus initial, 0 minus initial. Initial is minus 1, so the value will come as 1. So is this 1 the N factor of I negative over here? Definitely. Don't get confused with this 2. I'm talking about the N factor of this. Okay? And over here I've got only 1 atom of iodine. Right? 1 I negative I have. That's it. Very, very simple. Very, very simple. Got it? Very, very simple. Okay. I'm moving on to one more reaction. Okay, I'm moving on to one more reaction. Okay, this is the reaction which I showed you just now. Let me move on to one more. Okay, let me move on to one more. You can have a look on it. The same Cr2O7 di-negative in acidic medium. This H positive represents your acidic medium, converts H2S. It converts H2S to sulfur. And itself, this Cr2O7 di-negative gets converted to Cr plus 3. With this, I'm writing some water as well. Very, very simple. Now, the N factor of Cr2O7 di-negative in acidic medium is 6. We already know that. Now, people, what should be the N factor of H2S over here? For that, oxidation state of sulfur right here is -2, and it is getting converted to sulfur, and over here sulfur has got the oxidation state 0. So 0 is the final oxidation state of sulfur, -2 is the initial oxidation state of sulfur. So change in the oxidation state of sulfur, final oxidation state of sulfur minus initial oxidation state of sulfur, the value will come as 2. Okay, so 2 is going to be n factor of H2S in the reaction. Very simple, very simple, right? Great. People, if you got the n factors of both the substances over here, can we calculate their equivalent masses? Can't we calculate their equivalent masses? Very simple. Molar mass of potassium dichromate divided by n factor. Molar mass of H2S divided by n factor. That will give me the equivalent mass, right? Right? Great. I'm giving you few more reactions of the same K2Cr2O7. This is the reaction which just now I showed you. Now people, let me give you one more reaction over here. The same Cr2O7 dye negative, in acidic medium converts H2O2, hydrogen peroxide, H2O2 to, it converts H2O2 to oxygen. And itself this Cr2O7 dye negative gets converted to Cr+3, and with this it will give some water as well. Very simple. Okay, have a look. See, Cr2O7 dye negative in acidic medium, its n factor is going to be 6. Now people, I'm waiting for your answers. Tell me the n factor of hydrogen peroxide right here. Tell me its n factor. I'm waiting for your answers. Let me look at the chats from my phone itself. I'm waiting for your answers. Do it fast. Let me know the n factor of hydrogen peroxide right here. Okay, Dinesh is saying it's 2, Aarti is saying 2, Arman is saying 4, Suraj 2, Santosh 1, Sai Reddy is saying 4, Itishri is saying 6. A lot of people, lot of correct answers and a lot of incorrect answers as well. So, okay, have a look. Okay. See guys, over here, this is hydrogen peroxide, correct? Hydrogen peroxide. In hydrogen peroxide, is there a peroxide linkage between oxygen and oxygen? Hydrogen peroxide, is there a peroxide linkage between oxygen and oxygen? What is the oxidation state of oxygen in hydrogen peroxide? -1, right? What is the oxidation state of O2 over here? 0. Can I call this as the initial oxidation state of oxygen? Can I call this as final oxidation state of oxygen? So n factor is going to be final oxidation state, which is 0, minus initial oxidation state, which is -1, value will come as 1. This 1 is the change in the oxidation state for one atom of oxygen. But how many atoms of oxygen do we have? We have 2 atoms of oxygen. So I'll simply multiply it by 2. The value will be coming as 2. So 2 is the n factor of hydrogen peroxide over here. 2 is the n factor of hydrogen peroxide over here, right? Very simple. Correct? Okay. One more thing, guys. One more reaction which I'm giving you. Okay, this you can do. I'm just keeping it as such. You can do Cr2O7 dye negative converts Sn dye positive in acidic medium to Sn dye 4, and itself will get converted to Cr tri positive with some water. You can do it. Okay, people, just tell me the last one. This one. Just tell me the last one. Cr2O7 dye negative, it converts SO2. But in which medium? In acidic medium. It converts SO2 to SO4 dye negative. And we know Cr2O7 dye negative itself in acidic medium gets converted to Cr+3, and it will give some water as well. Right. Okay. Cr2O7 dye negative. Its n factor is going to be 6 in acidic medium. We saw that. What is the oxidation state of sulfur over here? It is +4. What is the oxidation state of sulfur over here? It is +6. +4 to +6. What is the change in the oxidation state? Change in the oxidation state is final oxidation state, which is +6, minus initial oxidation state, which is +4. Can I say the value will come as 2? So this 2 is the n factor of SO2 over here. Is this clear to everyone? Yeah? Is this clear to everyone? I'm looking at your chats. Tell me fast. I'm looking at your charts, guys. Wonderful. Flash extracts, guys. I have prepared the flash extracts. I'm expecting. I mean, it will be given to you today or tonight only. Okay, tonight I'll be providing you the flash extracts. Okay, I've made it already. It's with the operational team. They'll be sending it to you via Telegram, right? Okay. One more thing. People, just tell me this. Okay, now we have to talk about H2O2. Okay? Let me tell you, this H2O2, it can act as the oxidizing agent and it can act as the reducing agent as well. In some reactions, this H2O2 acts as the oxidizing agent, and in some reactions, the same hydrogen peroxide acts as the reducing agent. Okay? Now people, just have a look. I told you this hydrogen peroxide, it acts both as oxidizing and reducing agent. If it acts as the oxidizing agent, then this hydrogen peroxide gets converted into water. If the H2O2 hydrogen peroxide, if it acts like the oxidizing agent, then this hydrogen peroxide gets converted to water. If I'll ask you what is the oxidation state of oxygen right here in hydrogen peroxide, is -1. Over here it is -2. So from -1 to -2, what is the change in oxygen state? Change in the oxygen state will be equal to final oxygen state, which is -2, minus initial oxygen state, which is -1, correct? Which is -1. Can I say the value over here will be 1? Final oxygen state, which is -2, minus initial oxygen state, which is -1. The value is coming as 1. Is 1 the N factor of H2O2 over here? No way. This 1 is the change in the oxidation state for one atom of oxygen. But how many atoms of oxygen do we have? We have 2 atoms of oxygen, so I'm multiplying it by 2. So N factor of H2O2, when it acts as the oxidizing agent, is going to be 2. And remember, when H2O2 acts as the oxidizing agent, this hydrogen peroxide itself gets converted to water. Right? Now the point is, when the same H2O2 acts as the reducing agent, in the reducing agent, when it acts as the reducing agent, the same H2O2, it gets converted to O2. Right? See, what is the oxidation state of oxygen right here? -1. What is the oxidation state of O2 over here? It is 0. Right? If I want to calculate the N factor, it's going to be equal to change in the oxygen state, which is final oxygen state of oxygen minus initial oxygen state of oxygen, which is again -1. The value will come as 1. Is this 1 the N factor of H2O2 over here? No way. This 1 is the change in the oxidation state for one atom of oxygen. But how many atoms of oxygen do we have? We have 2 atoms of oxygen, so I'm multiplying it by 2. The value will come as 2. So remember, H2O2, it can act as the oxidizing agent, or in some reactions it can act as the reducing agent. If it is acting as the oxidizing agent or reducing agent, in both the reactions its N factor is going to be 2. Got it? People, is this clear to everyone? Is this clear to everyone? Tell me fast. Is this clear to everyone? I'm waiting. I'm looking at your chats only. Wonderful guys. Great. Okay, I think the time is up. I need to take a leave right now. So it was nice meeting you. Please go through the session again. Wherever you feel any sort of doubt, just let me know in the next session, or you can text me on the Telegram, Instagram, wherever you'll find me. Just do that. But go through the session again, okay? And whatever problems you'll face, just do let me know in the next session. Sharath, oxidation state of hydrogen remains same. Okay, that's why we do not consider it. Exactly, time flies fast. Yes. All right, guys, I need to take a leave now. I'll see you guys tomorrow at the same time with some good questions and even better concepts from the N factor calculation. N factor is not over yet, let me tell you. N factor calculation is not over yet. We have to do a lot of more things in this N factor, and tomorrow will be slightly advanced concept discussion from the N factor calculations. Okay, it was nice meeting you. I'll see you guys tomorrow at the same time, 5:30. Block your calendars with me. See you guys tomorrow. Till then, take care. Bye-bye. God bless you and love you all. Bye guys. Take care.